Hello everyone. So I'm Rekha Murthy, working as an assistant professor from EEE department. So now I'm going to explain about the third experiment of DSP lab, that is linear convolution of two sequences. So in this linear convolution, what is it? A linear convolution, it is a basic operation to calculate the output for any LTI system given its input and its impulse response. Okay, so in this linear convolution we are going to solve for the two different cases. Okay, the first case will be for the right sided sequence. We are going to provide the two sequences. So two sequences will be declared, that is x1 and x2. Okay, so it will be right sided sequences. Both the sequences will be right sided. And the second case will be related with the two-sided sequence, two-sided sequences. So let me give you the initialization, what will be the related with the right-sided sequence. In the right-sided sequence, the x1 and x2 value, if you are going to consider, the x1 value will be equal to 1, 2, 3, 4. And x2 value is 2, 3, 2, 4. Okay, so this the initial point will be starts with the beginning itself. So this will be x2 of 0, x2, this will be x1 of 0. So the initial value itself will be starting with the 0, x1 of 0, x1 of 1, x1 of 2, x of 3. Okay, similarly, when you consider for two-sided sequence, when you take x1 value, it will be given as 1, 2, 3, 2, 1, 3, 4, for example. And if you initiate that, if you're going to keep the pointer at this position, so it indicates that this will be the x1 of 0 and this will be x1 of 1, whereas x1 of 2, x1 of 3, it goes on. Whereas on this side, it will be x1 of minus 1, x1 of minus 2, x1 of minus 3. So the length will be starting with minus 3 to 3. But whereas here, it is starting with the 0 to 3 for the right-sided sequence. Okay. So the right-sided sequence, it indicates that the in the form of the graphical method. So 1, 2, 3, 4, let us plot this. x1 will be for 0 value, it is 1. Okay, for 1 value, it is 2. Okay, for 2 value, it will be 3. Similarly, for 3 value, it will be 4. So x of 1, this value will be 2. Okay, so this is how you will find all will be in the right sided. Whereas in the case of your two-sided sequence, it will be on the both the sides. When you consider this x1 plot, x of 0 value will be 2 and x of 1 value will be 1, position 1, and x of minus 1, the value is 3, the value will be 3. So we will find more both negative side also you will find the sequences, and also in the positive side, both the sides. Okay, so it is called as the two-sided sequences. Now how to write a program for case 1, when it is given data is the right sided, when both the sequence is right sided, and the input which you are going to provide is x1 of 1, 2, 3, 4, and x2 is again taken as 2, 3, 2, 4. Okay, so to perform this, the key function which you have to remember is just conv of x1 comma x2. So we are performing the convolution operation. Okay, that is a linear convolution, that is convolution conv of x1 comma x2, which will be equated to what? Y variable. So now let only this key function we have to remember, that's it. So now what is a x1? X1 is the input, that is enter the first sequence. Okay, similarly x2 will be the input, enter the second sequence. Okay, so this will be y is equal to this. Now we have to display it. How to display that? Make use of the key function disp, right? So if you want to put a text for a disp, the text which you want to type it as disp of linear convolution of x1 comma x2, and that value will be nothing but your y. Okay, so that is y, disp the y. This will indicate the value of y. So that value of y will be displayed the result of the convolution operation of between the x1 with the x1 with the x2. Okay, now how to plot this? We need to plot it in the form of a discrete form. So that is why which key function will you use? The stem function. So that is why we will write stem of what? Just y. Okay, and before we put this, okay, when you put this stem of y, we need to display, or we have to plot the different graphs. So the different graph will be totally there will be 3 graphs, one for the x1, one for the x2, and another for the result y. Okay, so for that purpose what I'm going to do here is I'm going to take one full graph, and in that one full graph, this will be the graph which you have taken, the first column, and in that the 2 rows which I'm going to initiate. This will be your first row and this will be the second row. Let me assume that in the second row, okay, in the second row we will display the value of the y sequence. Okay, and here we will divide it into 2 times. Okay, so that when you divide it into 2 times, so this column will be the second column and this column will be the third column. Okay, again subdividing. So that is why for that purpose we need to initiate subplot. We have divided the graphs, so subplot of what and what? That is subplot of the first the 2 rows. Okay, these 2 rows we have taken, so 2. Okay, the next one is the this is the 2 rows, so that is why we have to taken the 2 comma the first plot as usual, this will be taken as first. In middle what you will write is number of the initiation graph, the initially what you have taken 1. Okay, the next will be pointing out to the point 1, so that point 1 will be this one. So let me label this, so it will be taken as 2 1 1. So this is over. So 2 rows. Okay, then one first graph, the initiation of the first graph, and in that first one that indicates your the y value, because we have taken what? Stem y. So that is why we have interested with the y plot. So 1 we took, and then as usual give x label, okay, y label what we had written earlier, and the title. Similarly, now the remaining the 2 plots are left out. So for that purpose again we need to write subplot. Again how many rows we divided? 2 comma 2 comma 2 comma again we had divided this entire graph, the top 2 rows, and again we had divided the entire graph. This graph has been divided into the 2 columns, so that is why we need to write it as 2 columns. Okay, 2 rows 2 columns, this is rows columns, comma the which point we have to represent. Either you can select this or either you can select. So for safer side I'll go with this as x1 and this will be your x2. So therefore for x1 I have initialized to put it in this one, right, this plot. So this number you can't write it as triple 2, right? So that is why already the 2 has been declared. So take this number as 3. So this will be taken as 2 comma 2 comma 3, and again we need to write this, what you are going to represent the stem here. The stem will be related with your x1 signal, so we wrote that. Similarly, x label, y label, and title will be written as usual. The next part of a graph, this is over. Next part of a graph, again subplot. Okay, subplot, 2 rows, 2 columns, and here you don't initiate this as 3. 3 is over number, so therefore you take it as 4. In this window, the x2 plot should be displayed. So 2 comma 2 comma 4. So what will be the stem here? x2 plot. So therefore again x label, y label, the time index will be x label, y label will be the amplitude, and title. So this is how we need to execute the program for the right sided sequence. Okay, similarly when you consider for the case for the two-sided sequence, okay, in that case what will be the change I am going to tell you. Okay, the same thing we need to write x1, x2, y is equal to convolution. Before this we have to initialize different lines, because in this two-sided sequence we had taken the length will be different, right? The starting length will be x of minus 3 and ending length will be different. So that is why we need to declare the y begin and y end. Okay, so same thing which you will write, rewrite the key function y is equal to convolution of x1 comma x2. Okay, before I write that, we need to take up the initialization, that is y begin and y end. Okay, so how to write that? Y begin and y end, then ny. Okay, so ny indicates the length of that y sequence. Okay, so it will be started with a y begin is to y end. So what is this y begin, what is this y end, right? So this y begin will be nothing but n1 of 1 plus n2 of 1. That is your, this will be the x1 sequence. So there we have to add up the first element of a time vector. So we had taken n1 of 1 plus n2 of 1. So just like the sequence which will be given here will be x1 is equal to 1, 2, 3, 2, 1, 3, 4, right? The pointing point is here. Similarly, x2 is equal to 2, minus 3, 4, minus 1, 0, 1. So the pointing point here is here. So this will be x1 of 0, x1 of 1, x1 of 2, x1 of 3. So this will be x1 of minus 3. And this will be x1 of 1, 2, 3. Similarly here, x2 of 0, this will be x2 of minus 1, and this will be x2 of 1, 2, 3, 4. So x2 of 4. So that is why we have to add up the y begin. Where is that y begin here? The y begin value, when you convolute this y begin, so you need to add up this n1 of 1 plus n1 or n2 of the sequence. So n2 is the sequence for the x2, n1 will be taken as a sequence for the x1. So these two we need to add up. Similarly for the y end, for the y end what you have to write is n1 of, this will be the ending the length. So that is why we have to write the length of x1 plus n2 of length of x2, right? So when you declare this function, so we can perform the two-sided sequence convolution. and remaining the data. What will be the given data here? The given data value will be x1. What is the given data here? We need to declare x1, we need to give the input as x2, we need to declare the n1, n2. These are the inputs. So that is why x1 value will be the input 1, 2, 3, 2, 1, 3, 4. And what is the n1 for this? -3 and ending with 3. So we have to write it as -3 is to 3. Similarly, x2 value will be taken as what? 2 minus 3, 4, minus 1, 0, 1. What is the n2 value? That is -1 to 4. So we have to write -1 is to 4. So the remaining steps, what you have to write here, the remaining steps will be same as that of what we had written for the previous program. What is the next step we have to write? Display the value of this. The similar steps we need to repeat once again for the 3 different plots, that is subplot, that is disp linear convolution, and disp the y value, subplot 2, 1, 1, and get the stem, x label, y label, title. Similarly for the second plot, subplot 2, 2, 2, 3, the stem of x1, x label, y label, title. Similarly next for subplot, next subplot, that will be 2, 2, 4, stem value, x label, y label, and title. So this is how we can perform the linear convolution for both the given sequences. Okay, and here we need to observe the values of y, and it will be plotted in the form of a stems, so that can also be observed here. So we need to solve it theoretically, and we have to get conform with the simulated value.